The Genuine Article. Discussion and commentary based on articles from JACC.
Hello, I'm Tony DeMaria, the editor of JACC, here with another issue of the Genuine Article, and I'm sitting with someone who's known to virtually everyone in the cardiovascular world, Sir Magdi Yacoub, who's the professor at cardiovascular surgery at Imperial College in London. And he's just published an absolutely fascinating paper on the aortic valves and their ability to respond to stimuli. Magdi, why don't you tell us a little bit about the study?
Thank you, Tony. For a long time, we've been very interested with other groups in the biomechanics of the aortic valve and the biology of the cells inside the valves and what they do. And there has been many discoveries, but one of the recent things was to do with the contractile properties of the aortic cusps.
Now that's really interesting, Mag, because I think most of us from medical school have thought of the aortic leaflets as being relatively inert and fibrous structures that were passive, and your data would suggest otherwise.
Exactly. I think we were all told, and we thought that they were just leaflets responding to mechanical stimuli by just flaps opening and shutting. Not so. They predict events, they respond to events, and we now think that they actually modulate the flow and the tension on the cusps, the mechanical properties, and that could have many implications.
Now, in this particular manuscript, you looked at the influence of NO, as I recall.
Correct. What we did, Dr. Al-Hamamsi, in our group, in collaboration with the group at Georgia Tech, looked at the influence of the endothelium and endothelium-derived factors, mainly NO and endothelin, on the stiffness of the valve, and we found that they really did influence the mechanical properties of the valve in a region-dependent manner.
Yes, it was a fascinating experimental model that you used to assess these effects, to show the difference in tension of the aortic valve leaflets dynamically changing in response to NO or endothelin.
Exactly. And that was a biaxial model, taking into consideration this remarkable ability of the valve to respond in different ways, in different directions, and found that not only the contractile properties, but also the stiffness, the modulus of elasticity varied in response to these materials.
And so what are the clinical implications of this, Magdi?
If one wants to speculate, which we are convinced that the living aortic valve responds completely differently to an inert valve of any material, even the allografts, because they are not cellular anymore, that has clinical implications in terms of influencing coronary flow, durability of the valve, left ventricular function, and eventually, if you want me to speculate further, survival, because we have some data which are now becoming stronger and stronger, that the Ross operation, which is the only operation which maintains viability of the aortic valve in the long term, has a better survival and better quality of life. So we think that living tissue is really superior to anything in the aortic valve.
And I suppose this opens up the opportunity for pharmacologic intervention that may be beneficial in people who have early aortic valve disease in slowing the progression of the disorder, that might be a possibility.
Indeed, I think not only it affects physiology, but as you say, it could have an effect on pathology and early disease, and therefore if we can enhance endothelial function or any other dynamics, either pharmacologically or any other way, populating the valve with the appropriate type cells could have an important bearing on early aortic valve disease.
Yes, well, I can tell you that when the reviewers and the editors looked at this paper, we were all very excited. It represented something of a sea change in our thinking about aortic valve disease and the aortic valve leaflets, and I think it's really going to open up a lot of investigation in the future as to how we can use this. Congratulations on an excellent paper, and thank you for watching.
Have a question or comment about a CVN story? Send us an email at cvnfeedback@acc.org.